The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 2, Elementary Hyperbolic Geometry. Section 18, Ideal Points. If a system of lines is such that any two are coplanar, while they do not all lie in the same plane, and are neither parallel nor intersect, then they are all perpendicular to a fixed plane. If A and B are any two of the lines, they determine a plane pi, which is perpendicular to both. If C is any third line which does not lie in the plane AB, it is the intersection of two planes AC and BC, which are both perpendicular to pi, and therefore C is perpendicular to pi. Section 15, Part B. We shall call this system, which is completely determined by two of the lines or by a certain plane pi, a bundle of lines with an ideal vertex O. This plane pi is called the axis of the bundle. All of those lines of the system which lie in a plane are perpendicular to a straight line L, and the intersection of their plane with the fixed plane and form a pencil of lines with ideal vertex O. The line L is called the axis of the pencil. The ideal points thus introduced behave exactly like actual points. They can be regarded as lying outside the absolute and are therefore ultra-spatial or ultra-infinite points. Two ideal points may determine a real or actual line. Considering only points in a plane, the two ideal points are determined by two lines A and A prime. If A and A prime are non-intersecting, the common perpendicular to these lines belongs to both pencils, and is therefore the line determined by the two ideal points. If A is parallel to A prime, the line OO prime is a line at infinity. If A cuts A prime, OO prime is an ideal line which contains only ideal points. An ideal line lies entirely outside the absolute. Similarly, in three-dimensional hyperbolic geometry, we have ideal planes. It is left to the reader to show now that any two points, actual at infinity or ideal, always determine uniquely a line, actual at infinity or ideal, and that any 3 points, actual at infinity or ideal, always determine uniquely a plane, actual at infinity or ideal. These relations in 2 dimensions can be pictured more clearly if we draw a conic with respect to the absolute, or assemblage of points at infinity. Figure 26. Actual points are then represented by points in the interior of the conic, ideal points by points outside the conic. Lines which intersect on the conic represent parallel lines. Those which intersect outside the conic represent non-intersectors. If O omega and O omega prime are the tangents to the conic from an ideal point O, all the lines of the pencil with vertex O are perpendicular to omega omega prime. For the present, this may be used as a merely graphical representation. Its full meaning can only be understood in the light of projective geometry. See Chapter 3, Sections 5 and 6, and Chapter 5, Sections 1 through 14.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.